Good morning, everyone. Topic for today's session is Network Function Virtualization NFV. The agenda which I'll be covering will be what is NFV, what is Network Function Virtualization, how the standards of NFV is being evolved in ETSI through the ETSI ISG NFV group. And then we'll talk about 5G and NFV, how 5G architecture, 5G service-based architecture is suited for deployment on a network virtualized environment. And then we'll talk about the architecture, NFV architecture as per the ETSI standard. And we'll discuss about network service and end-to-end network service. And then we dwell upon MANO, management and orchestration of such network function virtualization, NFV. And then we'll talk about NFV infrastructure as a service, NFV IaaS. And then finally we'll talk about networking and software defined network, SDN. So let's start with what is NFV, what is network function virtualization. So let us have a look at traditional network. So this is a 4G network, a typical 4G network wherein you have different nodes. For example, this is packet gateway, this is mobility management entity, this is HLR or HSS we call it, OCS, PCRF and so on. And of course there will be routers when a traffic is has to go from one node to other node, and the switches. Okay, so now the problem with traditional network is that this particular boxes or nodes are purpose built hardware. So that means this particular box has been made to work as a PDN gateway, so it will work as a PDN gateway. This particular box is made to work as a MME, mobility management equipment, so it will work as MME. It is not possible that I can use this box, this P gateway box as MME or MME box as a HLR. So every piece of node or hardware is a purpose built, that is purpose of this box is to work as a PDN gateway and so on. So if an operator had say taken the equipment from one OEM, may say any of the OEM, maybe Nokia, Ericsson, ZTE, Samsung or whatever OEM it may be. So in case there is an expansion requirement of MME or P gateway, so the expansion equipment or the additional equipment the operator has to buy from the same OEM. So it's a kind of vendor lock. And then one has to negotiate, do a commercial agreement, buy, then there will be a supply coming to the operator, installation, and takes very long time to expand. So that's the problem which operator may be facing. The other problem is that once you are locked to one OEM, I mean you may not get a right price. Okay, so how to solve this problem? So solution to this problem is implementation of NFV, network function virtualization, and this concept is true for all generation of mobile communication including 5G. So our focus today will be on 5G, but it is applicable for all generation of the mobile technology. So what is NFV? Let us talk about. So in NFV, what is done is the purpose-built hardware is replaced by a generic hardware. So when we say generic hardware, we mean commercially off-the-shelf hardware from HP or from Dell or from any OEM for that matter. The second aspect is all the network function which is operating on purpose-built hardware will now become a piece of software. So network function has become a piece of software which will be deployed on a virtualized environment on top of a generic hardware. So with this, what we are doing is that network function and capacity are being separated. So now the network function is in software and capacity is coming from the virtualized environment, which is a physical hardware or the COTS hardware virtualized. So in case there has to be expansion in capacity, you just need to add more compute or more memory or more network on which this network function is working. We'll talk about that in upcoming slides also. And then once you have done that, so it is very easy to scale up or scale down. For example, if you have a virtualized environment wherein the physical hardware has been virtualized, and on those virtualized hardware your network function is working as a software. So in case there is a capacity enhancement requirement, what you all need to do is just add more hardware onto the overall schema and allocate more resources to particular network function or the virtual machine on which that network function is operating, and then scale up becomes easy. Similarly, if there is a less traffic, then you can also scale down, and in some cases even you can shut down some of the servers or whatever network element you have if that is not required. So what is the building block for this? So the virtual machine becomes a building block on which the network function will operate, or in some cases, or in most cases, it will be a container based architecture, which we'll dwell upon in upcoming slides. So what is network function virtualization? So network function virtualization has three parts of it. The first is that the network functions, so for example, your UPF in 5G, user plane function in 5G, or AMF, access and mobility function in 5G, or PCF, policy control function in 5G, etc. Will be softwarized in the sense that that will become a piece of software. And now you need to virtualize the environment, that is the hardware. You take physical hardware and then with help of some specific software you are virtualizing. So you have virtual compute, you have virtual memory, you have a virtual network. And now on to this virtual environment, this particular softwarized network function can be deployed. And once you have done that, you need to manage these. So for management you have orchestration, that is also called management and orchestration. So that will manage the entire softwarized environment, softwarized and virtualized environment. Now before we move further into it, let us look at ETSI ISG NFV, who is building the evolving the specifications. So ISG is industry specification group on NFV. So let's talk about that a little bit. So this is a screenshot of ETSI website. So if you go onto this particular page, you can see URL here. It is about network function virtualization. So it has got many things. So you have NFV, you have NFV proof of concept, NFV Plugtests program, NFV tutorial. So almost every document and associated programs details are here, and there are a lot of tutorial material, videos, etc. related to NFV. You can just go through all these things if you want to go into more detail. So let's talk about ETSI ISG NFV, that is the body who is evolving the specification of NFV. So basically ETSI ISG NFV is a home of network function virtualization. So under this initiative of ETSI, all the work related to NFV specification and other things are going on. So this particular group ISG was actually founded in November 2012 by 7 leading telecom operators of the world, and later on it was joined by most operators, OEMs, IT companies, and open forums, right? There are many forums who are working on open source uh, concepts for various IT related things. So they are also helping ISG NFV. Okay, so now from 2012 onwards, this particular ISG have published more than 100 publications, which includes various specifications, various reports, etc. So these are publicly available on ETSI website. You can just look at that. So all those specifications are there, and NFV, this particular ETSI also runs as part of NFV program. They run NFV Plugtests. So these are kind of an event, interoperability event, wherein various companies who are working on NFV network or the concept, so they come up with, they install their network uh, or the concept which they have, and then try to do an interoperability test among themselves. So this is a kind of event which is helping NFV evolve. And then they have also concept of NFV proof of concept. So those companies showcase the proof of concept onto certain events which is organized by ITSI. Okay, so every 2 years, ITSI ISG NFV comes out with a release on NFV. So as we know that it was formed in the year 2012. So from November 2012 to the next year 2013 and 14, it was a kind of an initial work on NFV concept, and they also tried to build culture or acceptability of NFV concept among various operators, OEM, etc. The next 2 years was the release 2. So during 2015-16, they came out with NFV release 2, which mainly focused on end-to-end interworking. So there was no release 1 concept, but during this initial work, a lot of papers were published and a lot of documents were created. So 15-16 was NFV release 2. Then after that, the release 3 came in 17-18. So every 2 years there is one release. So this was kind of enriching NFV architectural framework. This is enriching. This is spelling mistake here. And in release 4, which is yet work is being done, but whenever they do it, so there are many drops. So within 2 years there may be 1, 2 or 3 drops. So a few drops has come out. So this particularly is focusing on MANO part, management and orchestration, and also NFV enhancement for 5G is happening in this particular release 4. So this is important for 5G. So as I said that ITSI also runs a NFV plug test program, which is nothing but interoperability test, which is done by various open source communities and other companies, OEMs who are working, OEMs and IT companies which are working on this. So some of the open source community who is helping NFV program are ITSI OSM. So ITSI is leading this open source MANO Fog 5 Kubernetes. So Kubernetes is one of the important uh, it's a MANO. It's basically management and orchestration. So this is how this is a community which is helping NFV to evolve. Then ONAP, Open Air Interface, Open Daylight, Open Slice, Open Stack, Starlix X, and so on. So these are kind of a open source community who is helping NFV program evolve. So let's look at the 5G architecture and how it is best suited for NFV. So if you look at architecture, this is called service-based architecture of 5G. So all the architecture up to 4G was kind of a point-to-point architecture or reference point architecture, wherein one element, network element, talks to other network element on certain protocol defined by 3GPP. So there is a reference point architecture. So even for 5G, 3GPP has given reference point architecture as well as service-based architecture. But the deployment, the network deployment which is happening across the world is actually service-based architecture. When we say service-based architecture, basically in this, most of the network element, particularly the control plane network element, talk to each other over API. So this is in kind of a service bus, wherein one network element talks to other onto API, right? It's not a point to point. It's not this element is connected to a particular other network functions, but it is on a common bus, and as per defined flow, it can talk to any network element on API, and it will be a kind of API call. So once you have this kind of environment, all these network functions can actually be deployed as a software, piece of software or microservice, and then they can talk to each other onto the API. So this is what enables 5G SBA architecture to be deployed on a NFV infrastructure. Okay, virtualized infrastructure, it can be deployed because of the architecture which it has, and this has been created by 3GPP. So up to 4G there was no service-based architecture concept by 3GPP. Of course, some of the OEMs have actually implemented 4G in this way, but it was not there in the specification by 3GPP. Okay, so now this 5G SB architecture is suited for NFV. So let's now look at the NFV concept. So let us look at the NFV architecture as it is given in the specification. So if you look at this diagram, so let us talk about this. So on the bottom side you have hardware resources. It could be compute, which could be any server, Dell server or IBM server or HP servers, and then you have storage and you have network. So these are the physical hardware. It's kind of a data center having so many servers and storage, etc. Now this particular physical hardware is virtualized using some software like VMware or any other virtualization software, and now this environment gets virtualized, and you get what you get is the virtual compute, virtual storage and virtual network. So this piece is called NFVI, that is Network Function Virtualization Infrastructure. So this is a NFVI infrastructure onto which now the network element or network function will operate, and how they will operate is now onto this virtualized environment you can create multiple virtual machines. So VM1, VM2, VM3, VM4 and so on, or you can create containers. So both options are there. We'll talk about container a little bit later. So every virtual machine you can allocate certain compute, certain storage and certain network, right? So and onto these virtual machines you can deploy your network function as a software, and it is called VNF, virtual network function. So network function becomes virtual network functions, all because it is being deployed on a virtualized infrastructure. So now there may be a case wherein one network function, virtual network function, is deployed on more than one virtual machine, VM1 and VM2. Okay, so within the VNF you may have some part of implementation in VM1 and some part in VM2. So So that means one network function can either be deployed on one virtual machine or more than one virtual machine. So these are called VNFs, virtualized network functions. Now if you look at onto the right side, to manage this NFVI and VNF, you have management and orchestration. So NFV management and orchestration, network function virtualization, management and orchestration. So how it works, we'll just dwell upon that. So before you move into that, this particular picture shows how you can either use a virtual machine, onto that your virtual network function will operate, or you can use a container, and onto that either your VNF or any other application can operate. And this is possible on a hybrid kind of a multi-cloud. So it's not necessary that all the network elements are deployed onto only one cloud. So some of the network element can be deployed in cloud 1 and others on cloud 2 or in cloud 3, and then you can create an end-to-end network combining all those VNF. We'll talk about that later. Now let's talk about the virtual machine versus container. Onto the left side, if you look, so as I said that you have physical hardware, the infrastructure, and these are virtualized using some hypervisor software. So now you have virtualized environment, virtual compute, virtual storage, and the network. On top of that, you can create one virtual machine, second virtual machine, third virtual machine, and so on. And every virtual machine you can install a guest operating system, any operating system, maybe Linux or maybe Windows or maybe anything. And then on top of that, you can deploy VNF, one VNF or any other application. So you need a separate operating system for each virtual machine, and then on top of that you can deploy a network or application. In container, what happens is that you have infrastructure and the host itself is having its own operating system, and on top of that you installed a containerization application. So here it's shown as a Docker, which is one of the very popular software for making containers. You can use any other. So on top of that, now your applications can be installed. So this could be VNF or this could be any other application. So the difference is that here you had operating system in each of the virtual machines, wherein here there is only host operating system, and these applications are actually containing part of the operating system, but these are very light, and they use actually kernel of host operating system itself. So all those dependencies, bin, library are part of this, so that when you deploy this application, it will work in production environment without any problem, because all those dependencies are in the container. When you deploy a container, it is already there. So it becomes very easy to deploy as a application as a container, and you are saving on here you have multiple operating systems. So even if this particular application is not very much loaded, but the entire resources which is given to this virtual machine is kind of underutilized, and operating system is also consuming some of your resources. So here you don't have a specific operating system. So that's the advantage. So the question is that why the industry is preferring container compared to virtual machine nowadays. So all because the system resources are efficiently used, and then you can actually delivery cycle becomes very fast, because once you have a new software, so the containers are downloaded and just deployed. in few minutes you are able to either, if you need an expansion, you can do that, or if you need to deploy a new network function, you can do very fast, and then portability becomes very easy. So it's just like a downloading an app onto your mobile. So you can do it very easily. And then of course, so you can use a microservice kind of architecture. Those network functions becomes a microservice which can be utilized. So that's the advantage of container. So now let's again go back to NFV architecture slightly in detail and talk about functions. So as we discussed that on the bottom side we have NFVI, NFV infrastructure, consisting of physical server, storage, networking, and that is kind of a virtualized. Then you have a virtual compute, virtual memory, and the virtual network. And on top of that you deploy your network function as a virtual network function, so VNF 1, 2, 3, 4 and so on, and these are managed by EMs, element managers. So EM1 manages VNF1, EM2 manages VNF2. So we all know the element manager. So every network function today we know that is managed by a element manager. And of course on top of it you can connect your OSS, BSS. Onto the right side you have MANO, that is NFV MANO, NFV management and orchestration. So your MANO has three parts. So one is the VIM, that is virtualized infrastructure manager. So basically the virtualized infrastructure is here, which physical resources have become a virtualized resources. So management of this NFVI is done by virtualized infrastructure manager, VIMs. So it could be one, it could be more than one. So now let's look at VNF manager. So VNF manager manages this portion, that is VNFs. So for example, if a new VNF has to be created, so VNF manager does it, or some VNF has to be, say, removed, so this is done by VNF manager or even the modification part of it. And then on the top you have NFV orchestration. So the overall management of this entire environment is done by NFV orchestration. So if you look here, then there are various interfaces between individual elements here, and of course onto the left side. So for example, OSS BSS is through this MANO, and this is the interface it has got. So this is how MANO works in a simple way. So now let's understand the concept of network service in this virtualized environment. So if you look at this diagram, so this particular box, square box, this I have taken from ETSI, so one of the specification. So you see VNF, virtual network function 1, 2, 3, 4. So there are 4 virtual network functions, but you also have a PNF. PNF is nothing but physical network function, so the traditional network function. So network service is set of VNF and PNF and or PNF, and it is connected in a particular fashion. It is called VNF forwarding graph. So this set of VNF and PNF along with forwarding graph is called network service. And so between the two endpoint, whatever set of VNF and PNF we have, we then in entirety it is called end-to-end network service. So end-to-end network service could be like this, or could be like this, wherein you have two sets of network service. So this network service consists of VNF and PNF, and then these are connections, those are called forwarding graph. And this particular network service has got 3 VNF and they are connected on the forwarding graph, and these two are again connected. So now the endpoints are here. One endpoint is here, other endpoint is here. So from endpoint to endpoint, it is called end-to-end network service. So end-to-end network service could be like this. Okay, so now let's move to network function infrastructure as a service, NFVI AAS. Okay, so now you may have a infrastructure as a service, you may have a network as a service. So overall it is NFVI as a service. So if you just look at this particular diagram, so you have NFVI as a service, and on top of this you have VNF, or you may have any other cloud application. So for example, this portion of the NFVI infrastructure may be offered by IT giant like Microsoft, so Microsoft Azure, or cloud computing, or Google Cloud, or maybe Amazon Cloud. So the operators can kind of rent or buy or lease NFVI as a service from any of the service provider, and then they can deploy their virtual network functions or any other cloud application. So there is also a possibility that onto this NFVI as a service, this is a kind of a multi-tenant. So specifications also talks about multi-tenant support on NFVI AS. So maybe this set of VNF is of operator 1, this set of VNF is of operator 2, and the cloud app is from any third company. So this is how it can actually work. So multiple tenant can also be used in NFVI as a service environment. So this is yet another example taken from one of the ETSI document. So there are two domain 1 and domain 2. So domain 1 is say operator 1, domain 2 is say operator 2. So in domain 1, so basically, but if you so example is domain 1 is this, and domain 2 is the green one. So what it says is that domain 2 is having its own NFVI AS and VNF deploy onto that, and it has taken this NFVI part of NFVI AS and deployed certain VNF here. But if you look at the in totality end-to-end service abstraction, so it is of domain 2, right? So although the virtualized infrastructure it has taken from domain 1, but end-to-end service belongs to domain 2. So this kind of environment is also allowed as part of the specification. So now we had been talking about MANO, management and orchestration. So there is an initiative which is happening related to MANO by ETSI. So that is called ETSI OSM. So they are building kind of an open source MANO, and there has been a lot of release. In this month itself, in the month of October 2020, so they came out with release 8 of OSM, open source MANO. Release 8 is now available by this group. So this I have taken a screenshot of website osm.etsi.org. Okay, so this is what open source MANO is, an ETSI hosted project to develop an open source NFV management and orchestration MANO software Slack aligned with ETSI NFV. Okay, so now let's talk about networking. So we have talked about the communication network functions working as a software and deploy onto a container or onto a virtual machines. But the networking part is also important, because when we say networking, we are talking about various routers, switches, which connects to various network elements. for example, from G node B to core. So the traffic will pass through n number of routers, and there will be switches in between. So you are able to deploy a network function as a software very fast, but when it comes to networking, because if you look at the traditional network, so you have routers, you have switches. So now these routers have the control plane and data plane together. So all those management plane, control plane, or data forwarding plane are here. And then if you add a new network element, all these routers are to be configured so that the traffic meant for the new created network function is properly routed. So that's a manual kind of a work. Somebody has to remotely log in onto these network element and configure it. Or suppose in some cases some of the router goes faulty and the traffic going via this has to be rerouted like this. So all those configurations are done is not very efficient. So there is a need to automate it. So then comes SDN, software defined networking. So what is software defined networking? So what we do is that from these routers, the control and data forwarding planes are separated, and the control plane is centralized, and data forwarding plane are only handled by these routers. So all those management are centralized. So then it becomes a very flexible networking and IP routing, and then you can have a central view of all the resources. So in this way, even the routing becomes very fast, and from a central location, if a new node is added, you can just create all those forwarding detail, data forwarding detail, or data connecting detail very easy in a simple way. So that's what software networking is. So what is the benefit of doing all this? Because NFV is deployed on COTS hardware, so the capital expense become less. The flexibility of course will increase, because now one network element or one virtual network element can be deployed on any hardware, and it is decoupled from the location. So now it's not a location specific. So on any of the NFVI point of presence, NFVI POP, a particular VNF can be deployed, and then you can have alpha, beta, and production version of the release. You can handle, for example, if you have say developed a new network element, or the same network element, a new software is developed, so that you can deploy as an alpha, and only the set of traffic can actually float through the alpha, and you come to know about how it is performing. Then you can load more traffic, we call it beta, and see the performance, and if performance is fine, and then you can go to the production, and the entire traffic can be handling. So because of the NFV environment, you can use this kind of architecture when alpha, beta, and production deployment happens sequentially, and then any feedback during alpha and beta is actually plugged or taken care while we go to the production. So of course, rapid service innovation is one of the important benefit which we get. So software based service deployment becomes possible, and reduced power usage. So how reduced power usage? Because you will keep only those servers switched on which is actually required, and if there is no traffic, you can actually shut down. So you can actually shut down unused hardware, and then because you have a common hardware pool, so the resources are not wasted. And of course the interfaces are standard and open, so multi-vendor deployment becomes a reality. So these are some of the benefits of NFV. Okay, so we have come to end of our session. So we talked about what is NFV, what is Network Function Virtualization. We talked about the standard group ISG NFV, industry specification group on NFV. We just look at 5G architecture and how it is fitted for NFV kind of a deployment. We discussed about NFV architecture, network service, end-to-end network service, management and orchestration MANO, and the NFVI as a service, and then finally we talked about networking and SDN. So with this I finish my presentation. Thank you very much. So if you have any question, you can write in the I'll be uploading this on YouTube, so you can write onto the comment box and I'll try to answer. So at the end, thank you, and I would request that please subscribe to the YouTube channel so that whenever I do a new video on 5G, it reaches you. I mean, you can go through that whenever I release that. So as of now, more than 10 videos are already there, and I'll keep recording new video and uploading. So thank you very much for watching.